Hello and welcome to the Retus Academy. In connection with the straight lines, now we are going to see the pair of straight lines. Suppose if we consider two straight lines, which can be drawn like this. This may be the first straight line, and this may be the second straight line. It makes an angle theta 1 and it makes an angle theta 2 with respect to the x-axis. This may be the x-axis, and the resultant is, this is the point, this is the point of intersection of two straight lines, and phi be the angle between these two straight lines. Suppose if it is phi, then the vertically opposite angle also equal to phi. Okay, so this is phi and this one is theta 1. And this may be, suppose if you consider a triangle like this, and this may be the exterior angle. What is the exterior angle? The sum of the two opposite interior angles. So we can write theta 2 is equal to theta 1 plus phi. What is it actually? This is phi. Phi be the angle between the pair of straight lines. Okay. These two straight lines intersect at this point, and phi is the angle between these two straight lines. If it is phi, then the vertically opposite angle also equal, and it is also phi. And this is theta 1. This is an exterior angle of this triangle. It is equal to the sum of the opposite two interior angles. So from this we can write phi is equal to theta 2 minus theta 1. Okay. Suppose if we want to find the angle between the two straight lines which is intersecting, then we can find tan phi, tangent of phi. What is tan phi? Tan of, what is phi here? Theta 2 minus theta 1. Okay. So what is tan A minus B? Tan A minus B is tan A minus tan B by 1 plus tan A tan B. Okay. This is tan phi. Tan phi is equal to m2. What is tan theta 2? Tan theta 2 is the slope of, first tan theta 1 is the slope of the line m1. What is the line? First line. The first line, the slope of the first line is designated by a letter m1, and it is equal to tan theta 1. What is the slope? Tangent of the angle of inclination is the slope. Okay. And then what is m2 now? The slope of the second line, which is having the angle of inclination theta 2. Okay. This we are going to substitute over here. Instead of tan theta 2, it is m2. Instead of tan theta 1, it is m1. And it is m1 into m2. This is tan phi. Okay. Suppose if these two straight lines intersect each other in a perpendicular manner, say for example, one line is perpendicular to the other. Here this angle may be 90 degree. Okay? If the two straight lines intersect at an angle of 90 degree, what does it mean? One straight line is perpendicular to the other. So if the condition is like that, what is the condition for perpendicular straight lines? So let us see the conditions for perpendicular straight lines. What happens for tan phi? Tan 90. So tan 90 degree may be designated as, what is the value for this? Tan 90 is infinite, not defined. So infinite can be written as 1 by 0. So anything by 0 can be written as infinite. Suppose if you cross multiply this, then what is the condition? What is infinity? Anything by 0. So if you cross multiply this, we will be getting 1 plus m1 into m2 is equal to 0. Then what is m1 into m2? That is equal to minus 1. This one is the condition for the perpendicular straight lines or perpendicular slopes. So this is the condition for perpendicular slopes or perpendicular straight lines. Okay, say for example, let a1x plus b1y plus c1 be the general form of the first line. That means general equation of the first line, and a2x plus b2y plus c2 be the general form of the second line. Then what will be the condition for these two straight lines which are perpendicular to each other? Then what is the condition for that? a1x plus b1y plus c1 may be the straight line, general form of the straight line. Okay. The perpendicular line equation may be, so you have to interchange the x and y coefficient, like b1x minus, this plus should be written as minus a1y plus, it differs in constant. Okay. Suppose if it passes through some point, if it passes through some point x1 comma y1, then the equation may be like this. Here what happens? b1 x1, instead of x we are going to substitute x1, instead of y we are going to substitute y1, and a1 y1 plus k is equal to 0. What is k now? K is equal to k, just substitute everything over there, a1y minus b1x1. Okay, so this is the condition. Suppose if you are substituting here, then what happens? The equation may be b1x minus a1y. Okay, what is k now? Plus a1y minus b1x x1, a1 y1 minus b1 x1 is equal to 0. This is the equation which is perpendicular to the given line. Okay. Now we are going to see next the conditions for parallel lines. Suppose if these two lines are parallel, then what happens? If these two lines are parallel, parallel straight lines. Suppose if these two straight lines are parallel, now the picture should be like this. Okay. So both are having same angle of inclination, right? So and also these two straight lines having the same slopes. M1 should be equal to M2, or tan theta 1 is equal to tan theta 2, or there is no point of intersection, right? Parallel lines doesn't meet each other, so there is no point of intersection. So then there is no angle of, the angle between the two parallel straight lines are 0. Now phi is 0, right? Then tan phi should be written as m2 minus m1 by 1 plus m1 m2. It is recorded as 0. So what is the resultant now? Just cross multiply this. m2 minus m1 is equal to 0. What is this? m1 is equal to m2. This is the condition for parallel straight lines. Suppose again the general form of the equation is let a1x plus b1y plus c1 be the equation of the first line. a1x plus b1y plus c1 is equal to 0 be the equation. Then the parallel line equation should be like this. No need to interchange x and y coefficient like perpendicular lines. You just write a1x plus b1y is equal to k. It differs only in constant term. Okay, it differs only in constant term. Suppose if it passes through a point, passes through x1 comma y1, then what happens? a1 x1 plus b1 y1 is equal to k. So substitute for k in this equation, you will be getting a1x plus b1y is equal to a1x1 plus b1 y1. So this is the required equation for the parallel line to this general form of equation. So a1x plus b1y plus c1 is equal to 0 may be the equation. Then this is the parallel form of parallel lines equation of this. Okay, these are all the conditions which are used for parallel lines and perpendicular lines. Okay, for parallel lines, the angle between the two lines should be equal to 0. There is no point of intersection. So tan phi also 0. The condition is like this. Suppose if you consider these two equations, suppose what are the conditions for parallel straight lines? A1 by A2 is equal to B1 by B2. Suppose if you multiply this, A1 B2 should be equal to A2 B1. This is also a condition for a parallel straight lines.